Hi there, in this video I'm going to show you how to work out the second derivative given a set of parametric equations, okay? So in the last video I showed you how to work out the first derivative. So by first derivative I mean dy by dx, but in this video I'll show you how to work out the second derivative d2y over dx squared given a set of parametric equations. So let me title this second derivative for parametric equations. So let me take a red pen, underline this quickly. So in this case, if you're given parametric equations, so x is in terms of t, and if you're given an equation y in terms of a third variable which I'm naming t, okay? So in order to calculate d2y over dx squared, we need to apply the chain rule. So by the chain rule, to work out d2y over dx squared, so this is what we need to do. We need to differentiate dy by dx with respect to the variable, okay? So the variable, the third variable I'm naming as t, so we differentiate dy by dx with respect to t, okay? And then we multiply that by dt over dx, okay? So dy over dx will generally be in terms of the third variable, whatever that may be. So I'm naming the third variable as t. So dy over dx will generally be in terms of that third variable t. So you differentiate that with respect to t, and then you multiply the outcome by dt over dx. Okay, so this is the chain rule in order to work out d2y over dx squared given a set of parametric equations in terms of the third variable t for x and y. So let me highlight this. And let me show you how this result is applied by taking some examples. So here's an example 1. So question is, let's find d2y over dx squared, and in part A, x in terms of t is 2t squared, and y in terms of t is 5t cubed, okay? So we've been given a set of parametric equations for x and y in terms of our third variable t. X is 2t squared, y is 5t cubed. Now we need to work out d2y over dx squared. So the first step is to calculate dy over dx, okay? And remember, in the last video I showed you the method to work out dy over dx, the first derivative. So if you haven't watched that video, I would encourage you to watch it, okay? So that will give you an understanding in terms of how to calculate dy over dx. Let me show you anyway, as we need it for this problem. So in step number 1, so let's find dy by dx. So the first part to calculating dy over dx is we need to calculate dx by dt and dy by dt, okay? So let's calculate dx by dt. If I differentiate x with respect to t, when I differentiate 2t squared, that is 4t, okay? And let's work out dy by dt as well. So if I differentiate 5t cubed with respect to t, I'll get 15t squared, okay? So that's the first part to calculating dy over dx. The second stage is we need dt over dx, okay? So dt over dx, so that can be found by calculating 1 over dx by dt. Okay, so it's going to be 1 divided by, and dx by dt we worked out here as 40. Okay, now the third stage to working out dy over dx given parametric equations is to use a chain rule. So by the chain rule, dy by dx, so remember the rule in the last video, it's dy over dt times dt over dx. Okay, so that's the chain rule in order to work out dy over dx for parametric equations. So dy by dt we worked out here, we had 15t squared. dt over dx we worked out in a previous step, and we had 1 over 4t. So let's apply the results here. So let me continue on the reverse. So dy over dx, that is equal to, so dy by dt, that's 15t squared. So let's note that, 15t squared times dt over dx, we calculated that here, 1 over 4t. So that is 1 divided by 4t. Okay, so I can cancel one of the t's with the 1 in the numerator, okay, to give me an overall answer of 15t over 4. So that is the solution for dy over dx. Okay, now we need the dy over dx in order to work out d2y over dx squared, the second derivative. And remember, this is the chain rule for the second derivative d2y over dx squared. Okay, so let me show you how this rule is applied. Firstly, let me copy down that rule. So here is my step 2. So by chain rule, so d2y by dx squared, that is a d by dt of dy over dx, multiply that by dt over dx. Okay, so let's insert our results. dy over dx, we had 15t over 4, so 15t over 4, multiplied by dt by dx, so let's quickly remind ourselves, dt over dx, we had 1 over 4t, so let's include that here, so 1 over 4t. Okay, so from here on, let's work out d by dt of 15t over 4. So if I calculate d by dt of 15t over 4, I'll just have 15 over 4, and then multiply that by the 1 over 4t. So if I do that, d2y over dx squared, so multiplying the 15 over 4 by 1 over 4t, will give us a 15 divided by 4 into 4t is 16t. Okay, so that should be the solution for the second derivative d2 over dx squared. Okay, so from here you need to differentiate with respect to t your answer for dy over dx, and then multiply that by the result for dt over dx. So that is how this procedure is applied. Okay, so that completes part A, and here are the steps, and let's try another one. Okay, so here is a part B. So we've been given these parametric equations. So x is equal to 3t squared plus 4t, okay, plus 2, and the equation for y is equal to t cubed plus t squared. Okay, so let's do the same. let's work out d2 over dx squared. So the first step, step number 1, let's work out dy over dx. So remember the stages for dy over dx. The first stage, we need to calculate dx by dt as well as dy over dt. So dx by dt, when I simply differentiate 3t squared plus 4t plus 2 with respect to t, we'll have 6t plus 4. Okay? And if I differentiate y with respect to t, so dy by dt, if I differentiate t cubed, we'll have 3t squared. If we differentiate t squared, we'll have 2t. Okay? So that's the first stage for working out dy over dx. Remember the second stage, we need dt over dx. So dt over dx, that can be found by working out 1 over dx by dt. Okay? Dx by dt, we had 6t plus 4, so it's a 1 over 6t plus 4. Okay? So we worked out dt over dx, we know dy by dt, so now we can calculate dy over dx. Okay? So let me continue here. So the third stage to working out dy over dx, so let's use a chain rule. So by the chain rule, dy over dx, that is dy over dt times dt over dx. Okay? dy over dt, let's remind ourselves, we had 3t squared plus 2t. So 3t squared plus 2t multiplied by dt over dx, we had 1 over 6t plus 4. So 1 over 6t plus 4. So if we simplify, okay, so I'm going to try and simplify this by taking out a common factor in the numerator as well as the denominator. So if I take a common factor of t from the numerator, I'm left with a 3t plus 2. And let me also factorise the denominator. So if I take a common factor of 2 from the denominator, I'm left with a 3t plus 2 as well. And by doing this, I can cancel these terms, giving me a solution for t over 2. So that's the solution for dy over dx, remember. Okay? So I've simplified dy over dx, so if you can simplify, by all means do so. Okay? And now I'm ready to work out d2 over dx squared. So that takes us to step 2. So by the chain rule, d2y by dx squared, so remember the result, it's d by dt of dy by dx, multiply that by dt over dx. Okay? So let's use the data that we have in the previous steps. So it's a d by dt, dy by dx, our simplified result is t over 2, multiplied by dt over dx, and if you remember, we had 1 over 6t plus 4. Okay? So multiplied by 1 over 6t plus 4. So remember what I said in a previous example. From here on, differentiate t over 2 with respect to t first. So if I differentiate t over 2 with respect to t, we'll have half. And then multiply that by the 1 over 6t plus 4. So in other words, multiply that result by your dt over dx solution. So if we multiply, we're going to have 1 divided by, okay, 2 times 6t is 12t, plus 2 times 4, which is 8, okay? Or you could just as well factorize your denominator, okay? So it's going to be 1 divided by, okay? If I take out a common factor of 4 from the denominator, I'm left with a 3t plus 2, okay? So I'm going to leave my answer like that for d2y over dx squared. So that ends this example, okay? And that ends the video also. So here are the steps to working out d2y over dx squared, okay, given parametric equations. So I hope you enjoyed the video. If you did enjoy the video, a like will be very much appreciated. Do practice related problems.